Welcome. This question says, what is the pressure? What pressure is exerted by a right cylinder that has a radius of 2 meters, a height of 4 meters, and a density of 8 kilograms per cubic meter? This is a right cylinder. It's basically 90 degrees to the face at the bottom of it and 90 degrees to the face at the top of it. It's like a vertical column. Okay, so let's kind of visualize this thing. So this is like that, and the height is here, and we're given a radius r, and defines an area, and I want to know the pressure here. So I said, well, pressure is equal to the force divided by the area that the force acts upon, and the force of this will of course be the mass of the object times g over the area that the object defines upon. And it turns out we're not given the mass, we're given the density. Well, the density, the mass of the object, if I think about this, I go density is equal to the mass per unit volume. So the mass is equal to the density times the volume, which would be, let's put that in, density times volume times g over the area. And then our pressure is equal to density. Now our volume is going to be the base area, which is pi r squared, times the height. That's our volume, times g. And we've got to divide it by the area, and the area, oh look at that, our area is pi r squared. That area is used 2 times, 1 time on the top and 1 time on the bottom. So we get our pressure is equal to our density times h times g, which equals, looking at my numbers, it's 8 kilograms per cubic meter, which is great, times our h, height is 4 meters, height of 4 meters, times g, g is always 10 on Earth. So pressure is equal to 3 8s are 24, 4 8s are 32, 320 Pascal would be my answer. 320 Pascal, and yes, there's 320 Pascal is there. So it's a simple relationship. We had to work a little bit. We had to recall the relationship between density, mass, and volume. And then we had to be prepared to visualize. We had to turn around and say, well, okay, how do I find this area? Do I need this area? If you think in sentences, if you put down pressure equals and write the complete relationship down, rather than trying to do a little bit of volume on one corner of the page and then trying to work out an area on another corner of the page and then put them all together at the end. If you're thinking complete sentences rather than phrases, you'll see cancellations like that cancelling and that cancelling. I could have written this question and not even given you the radius, and it would have been a legitimate question. And if I did that in an exam, I know a number of people would say to me, this question's impossible because I can't work out what my volume is. And all I can do is smile and say, well, do your best. So not a hard question, but just, if you can think in sentences rather than phrases and let things unfold, keep your wits about you, then everything works out fine. And there we have it.